Thank you so much for having me. I know we're all kind of itching to get back to in-person meetups when possible, but it's been interesting for me being able to speak at different places around the world without having to hop on a flight for 8, 12 hours or more. So it's been an interesting couple of years, to say the least. For those who are celebrating St. Patrick's Day or Holy, so there's a lot of stuff going on today. So happy St. Patrick's Day and Holy to you. What we're going to be talking about is CycloneDX and Dependency-Track, both of which are OWASP projects, and they work together to achieve a lot of cybersecurity use cases. So real quick about me. I build stuff, I break stuff, I build stuff to protect stuff. I get paid to do stuff at ServiceNow. There's my contact information if you'd like to reach out. So we're going to be talking a lot about SBOM today. Well, we've been talking about SBOM for quite a while now, ever since the executive order in the U.S. Really hit. But my talk isn't necessarily about SBOM because a bill of materials or software bill of material is, by definition, a small subset of the problems that we actually care about. So we're going to be talking about a bill of materials and software being part of that in this conversation. The two projects that we're going to be talking about today, excuse me, is CycloneDX, which is a bill of materials standard. It is a flagship OWASP standards project, and it's used by many, many organizations. We're also going to be talking about OWASP Dependency-Track, which is another OWASP flagship project, a tools project, and its job is to consume and analyze bill of materials such as CycloneDX. So real quick, just to kind of level set at a very, very elementary level, this is what a bill of materials is. If I want to make risk-based decisions, for example, if I have allergies to tree nuts, this might be something that I would care about. In the software world, we're not necessarily looking for the presence of nuts, but we might be looking for the presence of Apache struts. Here's a really interesting talk given by Alan and Frederick earlier this year. If you want to have a little bit of informative and entertaining session, this is a good talk to visit. And of course, Klaus is going to be talking a little bit about SBOMs as well right after me. So a lot of what we're talking about, however, was as a direct result of the executive order. And it's not like the U.S. government tells everybody what to do, but the reality is that the U.S. government has a really big purse. They procure a lot of software, and because of the expenditures, the amount of money that's allocated for software and other things, it has a really big impact on pretty much the entire software industry. So that's kind of one of the reasons why we're talking about that, and I know Klaus is going to be hitting that a little bit harder right after this talk. But let's dive into CycloneDX, which is that bill of materials standard. Again, it is a flagship OWASP project. It's probably unlike other OWASP projects that you might be familiar with. CycloneDX actually operates as a meritocracy, very similar to the Apache Foundation. We have different working groups. We have a formal governance process. We have a formal standards process. And we take a risk-based approach to standards development. The spec is highly focused on cybersecurity use cases, although there are other non-security use cases that we also support. And as part of our risk-based approach to standards development, we release yearly revisions of the spec, which are backwards compatible. It is recommended by multiple world governments, and it has a really big industry of adopters and supporters and vendors that support the spec. But it's not an SBOM standard. It's actually a bill of materials standard, and software is just one of the really important things, but it's just one of the things that it can actually represent. Software or SBOM is one, but we also support things like OBOM, or operational bill of material, where I can represent not only the stack for my application, but I might want to represent the operating system or the hardware that operating system is running on, or the VMs and the deployment information of where it's running at. I might want to, if this application, for example, is an IoT camera or an IoT toaster for that matter, I can describe the full stack, including all the hardware, the device drivers, and everything else that makes a shippable product. I could also describe services. Software hasn't lived in a vacuum for 20 years. And the fact that we're talking about SBOM is nice. It's a good starting point, but it leaves out half of the equation, which is services. So not only can you describe services within CycloneDX, but you can have an inventory solely of services, which is a SASBOM. This is actually a cloud security recommended practice. And you can also describe the vulnerabilities that is in my inventory of software, hardware, and services, and if any of these things are actually exploitable or not, which is, if I'm a consumer of software, that's actually what I care about, right? The inventory is nice to have, but as a consumer of software, I want to know what things I should worry about in my environment so I can protect those things. CycloneDX is used, again, by a lot of organizations. There's estimated 100,000 organizations using this in production today. And these are some of the projects and vendors that support the spec. These are just the ones that we know of. I'm sure there are many, many more. But interestingly enough, multiple world governments have come out in support of CycloneDX. And NCSC, right here in the Netherlands, was one of the first last year to actually come out in support of CycloneDX as their preferred format. So this is it's an interesting read. I would highly encourage you to take a look at it. It has some really good use cases for SBOM that they go through and why they were leaning towards CycloneDX as their preferred format for this. So give this a read. It's interesting. CycloneDX, at its very core, going back to that very elementary use case, can describe a complete and accurate inventory. That's really the foundational use case. But we can also use it for vulnerability analysis, right? Once we know what the components are, great. Now I can actually analyze them for known vulnerabilities. That's a basic risk management use case, which is why the executive order was created in the first place. But we can also do things like integrity verification, right? Is my components, have they been altered since I actually got them from Maven Central, or maybe there was some malicious things in the transmission of that package to my environment. I can do integrity verification. I can actually analyze the software package itself. Does the project have maintainers? Does it have do they answer support tickets? Do they do basic good practices, best practices when it comes to software engineering for their respective open source project? Obviously, cybersecurity isn't the only use case, but we can also analyze it for license and intellectual property use cases. CycloneDX can describe component assemblies, and I kind of equate this to like a dashboard in an automobile, right? A dashboard in an automobile might contain a instrument cluster. And within the instrument cluster, you might have a speedometer or tachometer. And within that speedometer, you might have plexiglass and LEDs and capacitors and all these things, right? And that exploded component hierarchy is what we call a component assembly within CycloneDX. It's a way to describe really, really complex software component architectures in an SBOM. But open source is the ultimate supply chain. Components can and will be modified, renamed, redistributed ad infinitum. And we can describe that component pedigree, the lineage of all of these changes and where they were derived from in my SBOM. And where you got that SBOM from is also really, really important. Did I get it from a public repository like Maven or NPM? Did I get it from a certain supplier, such as Microsoft or Oracle? Did I get it from a certain country that might have sanctions against it? I don't know. But provenance is a story of origin, and we can describe that in CycloneDX. And we can also describe our reliance on services, such as if I have a bill of material and I have a component within that bill of material, and maybe that component, for example, reaches out to grab stock tickers off the internet. Well, that component technically doesn't have any functionality by itself. It relies on a third-party service. I can include that service in my bill of material and that dependency relationship as well. And there's, of course, a lot of other use cases that you can do with CycloneDX. Really briefly, this is a lot of data, I know, but this is essentially at a very, very high level, the object model of CycloneDX. At the top, we basically have the information about the bill of material and about the components, typically a software component, but it could be a hardware component, about the component that the bill of material is for. In the blue, we can describe things like applications and frameworks and libraries, containers, devices, firmware, etc. We can describe the services and the endpoints, trust boundary traversals. We can also describe the type of data, the data classification, and the directional flow of data between component and service or between services. We can describe the dependency relationships. If one component depends on something else, no matter if it's a software component or hardware component or a service, we can describe those relationships as well. We can also describe the completeness of these things, right? If you're creating bills of materials in your build pipeline, you may not necessarily have complete 100% transparency of everything that you're including, right? So you can describe how complete you think this bill of material actually is. And there is no wrong answer, right? If you don't know, that's fine. You can actually state that in your bill of material. Likewise, if you are only including third-party components or including only first-party components, or if you think that the bill of material is completely complete, there's ways to specify that as well. You can describe vulnerabilities. CycloneDX is actually a bill of vulnerability spec as well. But you can describe the vulnerabilities affecting the software components, the hardware components, and the services within your bill of material. And you can describe the exploitability of those things, which is really what the end consumer wants to know in the first place. And finally, CycloneDX is extensible. There's a lot of different ways that you can extend it to do different things while still conforming to the specification itself. There's a lot of different ways to create SBOMs. I'm not going to go into all of them in detail. Here are some of the more popular ones, starting with SCA tools. This is kind of the easy button for a lot of organizations where you might have an SCA tool, whether it's commercial or open source. Many of them already support CycloneDX. If your vendor does not, please ask them to do so. If vendors want to be relevant in this space, they need to support SBOM. And CycloneDX is the leading SBOM format for cybersecurity use cases. So it's in SCA vendors' best interest to support this. But for the most part, this is an easy button because a lot of organizations already have this. However, SCA tools are not designed to describe complete and accurate inventory. They're designed to identify risk, which is why integrating bill of material creation into the build lifecycle itself is a really good option. You typically get a much more accurate representation of your inventory by doing this. But it does take a little bit more work. You can analyze a source repo for bill of materials, right? Not overly useful for most cybersecurity use cases. There are a few, but this is more for license and intellectual property use cases. This is really useful for those. You can actually create SBOMs at runtime, right? Through IAST or through, there's certain mobile platforms for iOS and Android that you can create dynamically from your device, a bill of material, not only the other components that your application is shipping, but the components, maybe the native components on that device that are actually invoked by your application. You can target the factories themselves. These are things like Jenkins and GitHub Actions and these types of things. So instead of integrating it with the build lifecycle, you can integrate it with the factory, and you may not necessarily have the most accurate results, but it's a really easy way to get a lot of results really, really fast. And, there's still some ecosystems, C and ++, for example, that still have practices dating back 30 years. And in those cases, they manually manage dependencies for the most part. In a lot of cases, they're going to have to manually manage their SBOMs as well, unfortunately. CycloneDX, the website, does have a lot of use cases and examples. Examples are published in both XML and JSON. JSON is the preferred format. However, I would also take a look at the XML examples. Not that I want you to use XML, but because XML as a format supports comments, it's actually easier, in my opinion, to actually look at the examples in XML, because many of the XML examples do have comments, whereas the JSON ones do not. And finally, visit the CycloneDX Tools Center. This is a marketplace of free open source commercial tools that support the spec. I think we're up to close to 120 or so tools, both open source, commercial, etc., that support the spec. So if you're getting into SBOM for the very first time, check out the Tools Center. This is really going to save you a ton of time. In terms of participation, check out the website. We have our own GitHub organization. We also have our own dedicated Slack workspace. So most OWASP projects, they have a dedicated channel within the OWASP Slack workspace. We actually have our own dedicated workspace. This is one, for historical purposes, and two, our Slack is pretty big. We've got like 20 some odd channels just for Cyclone. So we have our own workspace as a result. We do technically have a mailing list, although there's not a lot of activity. It's really there to support those folks in government who just cannot get access to Slack because of policy. We're also on LinkedIn and Twitter if you want to follow us there. But now that we talked a little bit about bill of materials, I want to dive into, once you have a bill of material, now what? What do you do with it? That's really where Dependency-Track comes in. So what does it do? It consumes, it analyzes, and produces bills of materials at high velocity. That's interesting. Which means it's ideal for use in modern build pipelines. But it's also good for procurement and M&A. If I'm purchasing a piece of software from a vendor, or maybe I'm purchasing a company, which is what I do in my day job. I look at these companies for various cybersecurity risks. It's really, really good for these types of manual use cases as well. It's designed to answer one question. What is affected? Log4j, and where? My application version 1.0. So if I'm an enterprise with tens of thousands of assets in my environment, I really, really care about this one fundamental question. What is affected and where? Conceptually, this is what it does. I have an asset. It could be a microservice, monolithic application, could be an IoT toaster, or even a thing like, a server. I have an asset. I have a bill of material for that asset, and I continuously analyze it, and everybody's happy. Going down a few hundred feet, this is still at a high level. This is what it does. On the left, we produce the bill of materials. We can do this in a CI/CD pipeline, pretty easy. There's lots of tools that do this. You can get them from suppliers. However you get your SBOM, the next step is then to ingest it into Dependency-Track. Dependency-Track has an API first design, so you can use curl, you can use a Jenkins plugin. There's a bunch of other tools that you can use to upload to Dependency-Track. And once it's in Dependency-Track, it analyzes for security, operational, and license risk. And it doesn't wait for bills of materials to be analyzed, though. It's going to continuously analyze your inventory at a minimum of every 12 to 24 hours. I can't remember what the current cadence is, But every day at a minimum, your inventory is going to be constantly analyzed. But keeping all that data inside Dependency-Track isn't really useful, right? You need to make risk-based decisions, more real-time risk-based decisions based on this data. So we have webhooks and a bunch of other things that allow you to get as much data as necessary to, one, understand what is affected, where is affected, and kind of the severity or importance of what it is that you need to do. That way you can perform certain types of automated actions as a result of your analysis. So with that, let's actually dive into a demo of Dependency-Track and see what it's all about. So I'm going to stop sharing this and share another window real quick. And bear with me real quickly. There's my other window. There it is. Okay. When you first log into Dependency-Track, you're going to see a window that looks like this. You're going to see a nice little dashboard with time series metrics, and it's all, good and pretty and all that. Now, Dependency-Track is kind of organized by projects. And a project could be, a project could be anything, really. It could be a microservice, monolithic app. It could be the IoT toaster. It could be an automobile, right? An automobile has, 20, 30 different software systems running at any given time. So a project is just a container, I guess, of inventory. And as you can see here, I've got, looks like 7 projects defined. And I can go into any of these projects. For example, I'll take the first one and I can see my inventory of components, right? But I'm actually going to create a new project. And, I'm going to do WebGoat just because it's an OWASP project and we're at OWASP. So let's see. Oh, I can give it some tags. That way I can search for it in the future. Vulnerable by design. Yes. So I can create that project. And once I actually have created that project, I can go into my inventory and upload the bill of material. And let's see, where is it at? There it is. All right. So if I refresh this, yeah, I have 136 components in my inventory now. And it looks like I have some of which that have vulnerabilities. But over here, you've got the component name and version. You have an indicator whether or not it's out of date or not, or if it's the current version. If that component is, if that component's ecosystem supports grouping or scopes, you'll have that here. Whether or not that component is internal to your organization is here. The license, we support all SPDX license IDs. We have a basic risk scoring mechanism and, of course, the vulnerabilities as well. Let me refresh this. Oh, here we go. I think this have to refresh the whole thing. Okay. If we go into the dependency graph part, we can also drill down to the transitive dependencies. For example, this is a Maven multi-module Maven project, so I can kind of drill down into my dependencies like this. Now, this is one way that we are representing dependency graphs today, but we're actually working on a few other ways to visualize our dependency graphs in the future. So if you have any ideas for that, let us know. But the primary purpose that we're all here for is to identify known vulnerabilities, right? It's great that I have an inventory, but I want to know what my risk is. So this is a way for you to kind of audit or triage the findings from the analysis. If you are familiar with Fortify or any other static analysis tool, this concept, this workflow is going to look really, really familiar to you. So let me just choose the first one here. I'm going to expand that. It gives me a title and description of what the vulnerability is. It has an audit trail. Oh, that's interesting. It allows me to make comments on this. For example, maybe I'm not actually exploitable to this. Well, I can make that kind of comment here. I don't think this is exploitable because I cannot spell today. And I can add that to my comment trail. I can also make analysis decisions based on this. So if I'm really not affected by this vulnerability, then I can mark it as such, and that becomes part of my comment trail. Now, we talked a little bit earlier about the concept of VEX, or Vulnerability Exploitability Exchange. What I'm doing now actually is part of that. So if you are a software vendor, this is where things really start to get interesting for you. So I can make my analysis decision, and if I'm truly not impacted by this vulnerability, I can go ahead and suppress the finding. That way, my metrics, time series, risk scores, etc., are not actually impacted by this particular vulnerability. Now, I have an ability to have a justification on this, right? I'm not affected by this because of, maybe the code is not reachable because I'm not using that particular method in this class, right? And then as a vendor, I can say what my response is going to be. I'm not going to update, right? So I'm not going to fix this because that code is not being reached. It's technically not exploitable, and I'm not going to fix it, right? That might not be the response that we would all like to have, but that's going to be a response that a lot of vendors will undoubtedly make. And of course, you can provide some details about workarounds or all kinds of other things after the fact as well. But this information becomes part of your audit trail and part of the VEX. So if you are a software vendor, this information you can provide your consumers. You can provide your consumers the bill of material of, in this case, WebGoat 8.0. You can also provide your consumers the VEX as well to tell them things that you are not exploitable to. If I had any policy violations, they would be here. I don't have any policy violations defined right now, so I'll get back to that in a minute. But just where I had the ability to upload the bill of material, I also have the ability to download the bill of material. So this actually dynamically generates a bill of material for you. It doesn't actually keep the one that I just uploaded because I can change it through APIs or through other means. But these dynamically create the bill of material for you on demand, and you can request the bill of material for just the inventory, or the inventory with the vulnerabilities, or just the VEX. The most common way that you're going to, if you're a software vendor, the most common way you're going to do it is you're going to provide your customers an SBOM of just the inventory and basically a VEX BOM, or just the vulnerability exploitability exchange without any inventory information. Those are the two files that you would typically provide consumers of your software. Now, everything I'm doing here in the UI can be automated, right? It has an API first design, and behind the APIs, there's a lot more functionality than what you see here in the UI. So I'm showing you the UI just because it's just a better demo. If I showed you something with GitHub Actions or Jenkins or something like that, it would just look like magic, and you would be done in like 5 minutes. But the manual use case is really interesting to look at because you see kind of the workflow. But it also kind of shows you how you might use this for procurement and M&A, where you're not actually building your own bill of materials. You're actually getting those from other vendors and using Dependency-Track to analyze the bill of materials that you're getting from these other vendors. Now, WebGoat, the bill of material for WebGoat doesn't have any services defined. I want to show you one. I think I have one. Yeah, I got a service example here. In this particular case, just for simplicity's sake, I have a single component. And that single component is this Java ticker client. And its sole purpose is to rely on this external service. And this is the ticker service. And if I go into the ticker service, it will tell me information about the provider, contact information. It will tell me the endpoints that this particular service has. It'll tell me the data classifications and the directional flow of data between that component and that service, as well as any external references for documentation, etc. So this kind of completes the whole holistic view of inventory, right? You can describe your components and your services collectively in your inventory, which is really important. But the primary use case was, was vulnerability management. And a lot of cases, we might want to find, for example, the presence of, Log4j, for example, right? We can search for things like Log4j. Do I have any here? Yeah, I got some Log4j in my environment. And again, if I have tens of thousands of assets in my environment, being able to very quickly know where I'm running Log4j, this is huge. In December, when this came out, many organizations were spending weeks just trying to determine where Log4j was running in their environment, let alone fixing it. With bill of material and things like Dependency-Track, this is really like a 5-minute job. This is not hard at all. In fact, I think one of the financial services in this companies here in the U.S., Goldman Sachs, actually did a blog post a couple of weeks ago kind of highlighting that point. When Log4j happened to them, it wasn't really a big deal. They were able to because they used Cyclone, they used Dependency-Track, they were able to find out where they were using Log4j and spend most of their time fixing it instead of finding it. But you can also search for things the other way. So, for example, I don't know if I have any, I don't know but I want to search for maybe like Jackson data bind vulnerability, right? So maybe I want to search for, if I can remember this, I think it's this one. Yeah. So if I want to search for this vulnerability right here, this is Jackson data bind vulnerability. It tells me a little bit about it, but it also tells me what assets, what projects in my environment are actually impacted by this vulnerability. This is huge. So as I'm watching the news and I hear about this new vulnerability of the week, I can now go into Dependency-Track, type it in, and see what projects in my environment I'm actually affected by this thing. So this is a really big, important use case. But again, cybersecurity isn't the only use case that we support. We also support licenses. SPDX license identifiers are supported. We will be working on to expand our license support to include SPDX license expressions as well. So, for example, something is licensed with this license or this license, or this license and this license. So we'll be working on expanding that in the future, but we have some basic license support today. But we do have policies, right? And a policy evaluation engine. So, for example, if I wanted to have a policy that I wanted to fail all builds on for anything with Apache struts, right? That would be a really good policy to have, right? Maybe I don't want struts in my environment. That would be one way that I can actually accomplish that. But you can also do other things, right? You can do it based on severity of vulnerabilities. You can do it based on license groups. We have these thing called license groups over here. They ship out of the box with some predefined ones, but you can change these to your heart's content, add new ones, change it all up if you want. Each one of these have a bunch of open source licenses already kind of defined in them. We had to rely on a lot of public information to be able to create these license groups. It's certainly not as comprehensive as you would expect to find from a commercial SCA tool with their own legal team, for example. We had to rely on publicly available information to have this kind of list. So if you do have your own legal team, you can certainly expand this to your heart's content. So you can define maybe I don't want any copy left in my environment. That would be one easy way to do it. Or maybe there's just one license that I really don't want in my environment. Maybe I don't want I don't want this license. AGPL. I'm allergic to AGPL. So that might be something that I might have a policy on. But I can also do different types of component identities as well. Package URL. I can do it based on CPE. I can also do it on with tag IDs. The interesting thing, what's this? All right, yeah, okay. I'm actually running an alpha version of the Dependency-Track. So not only am I praying to the demo gods right now, but I'm like really crossing my fingers at the same time because this is like unreleased alpha quality software I'm demoing right now. But anyway, it does have a pretty robust policy engine that a lot of organizations take advantage of. And finally, it has a bunch of administrative controls. It supports different analyzers. It has an internal analyzer that mirrors the contents of the NVD, as well as uses GitHub security advisories. It integrates with Sonatype OSS Index, which is a free service from Sonatype. If you have a subscription to VulnDB from Risk-Based Security, it supports that as well. You can configure how you want the NVD mirroring to work. You can configure how whether you want GitHub advisories enabled or not, and then what is your personal access token for that. And for identifying whether components are out of date or not. It has to support a bunch of different repositories as well. And there's a number of different ecosystems already supported in here. My computer went to sleep. And, you can add them and change them. And, so if you have internal Artifactory, Nexus repos, etc., you can add them here. So that way you can determine whether your internal components, for example, are out of date or not. It supports a bunch of different notification platforms. For example, WebEx, Teams, Slack, webhooks, etc. And then finally, we support LDAP, OIDC. We have an internal user management as well. I wouldn't recommend using it. Use OIDC would be my recommendation. But anyway, that's kind of Dependency-Track in a nutshell. Let me switch back to the deck. I'm almost done here. And I'll take a little bit of questions at the end, I think. Let me share. There we go. So again, the Dependency-Track site has its own website. It has its own GitHub organization. This project does use the OWASP Slack workspace. We have this hashtag Dependency-Track project on Slack. I invite you to participate in. It's pretty active. There's a lot of really good community members there, adopters. People are trying it out, etc. So it's a really, really great community of folks. We also have a Twitter account if you want to follow that as well. And with that, thank you so much for listening to me talk about Cyclone and Dependency-Track for the last, 45 minutes or so. I appreciate it. If there's any questions, I'll open the floor for questions at this time.
Ben de Haan stating that it's a very interesting talk. What is your experience on CycloneDX adoption with software vendors? Are you seeing any significant growth there? So, Steve, any information on that?
I am seeing a lot of adoption. It's really interesting when you create something, how you think it will be used. Versus how it actually is being used. Because it has a lot of different capabilities, mostly security capabilities, there's some use cases and some vendors that are working on that are really interesting that I wouldn't have never thought of. So yes, it's being adopted by like SCA vendors and this type of thing. For example, Grammartech and Sonatype, Sneaks, in the process of adopting it. There's all kinds of Veracode. There's all kinds of vendors that currently support it, like in the SCA space. But once you get outside of SCA, things like contrast security, right? They can actually dynamically generate bill of material at runtime, which is pretty cool. Now Secure supports mobile. You can do it dynamically at runtime. I'm seeing really interesting happenings in forensics. So being able to analyze the firmware on running devices, for example, and generate CycloneDX from there. I'm seeing CycloneDX actually being used in SOCs. So your Security Operations Center, where they might use the CycloneDX bill of material as kind of a baseline of what that application is, both the inventory and the services that it should talk to, and then using that baseline to detect anomalies, right? So there's all kinds of really, really interesting things I'm seeing around CycloneDX. I'm also seeing a lot of innovation around distribution of SBOMs and signing of SBOMs, and even a marketplace of SBOMs for open source projects. There's just a ton of innovation happening in this space. And I think a lot of that innovation not only stems from the EO, right? Whenever the federal government says, do this thing, you're always going to get a bunch of startups and whatnot doing that. But because of its focus on cybersecurity use cases, we're seeing a lot of really interesting things that weren't necessarily planned for, really. I mean, people are looking at the capabilities of Cyclone and thinking, oh, I could also use it for X. So we're seeing a lot of innovation that we clearly didn't think of long ago when we started down this journey.